Dear members of the jury, dear audience, welcome to our presentation of the Informed or an Analytics Student Team Competition 2017 here in Las Vegas. We are really glad to be here in order to present you our final findings, which are the result of 6 months of hard work and sleepless nights. Just as a reminder, we were asked by the firm Syngenta to help them in the selection of the right soybean varieties. Indeed, they are facing some problems since they are commercializing seeds they shouldn't, since they didn't reach the 1 million of bags sold in the second year of commercialization. Sorry. But Robert Heisse here and Henri Lourti and myself, Charles Heymans, are students of the Louvain School of Management in Belgium, as being said. We are all Master 1 students studying business engineering. Charlene Corbet, the unique girl of our group, couldn't be with us today since she started an internship in London. Let's move on now to the agenda for today. So basically, in the first part, we'll describe how we firstly understood the problem. Following that, we will talk about our model building, which includes a lot of database modifications. We'll talk about the significant locations, try to incorporate in some way the graduation year effect. We'll go deeper through the RM and yield analysis. We make a comparison with the Czech yields and the elite yields before making some clusterings and interactions among the different groups. Once we will have reached our final model, we'll discuss our significant variables. We'll be able to make good predictions and to select finally the right seeds for Syngenta. In the final part of our presentation, we'll talk about the limitations we face regarding the database, and in our conclusion, we'll try to convince last time of the quality of our work. So when we firstly received all the database, we were kind of lost. Indeed, we didn't have so many insights on all the characteristics of soybeans. Therefore, we decided to go on Syngenta's website and looked at the seed and all its characteristics. We saw a variety could depend on its relative maturity, its yield, and depend on the environment, which are the locations. All those informations were provided in the database. However, some characteristics such as resistances, tolerances, or suitability for soil were not provided in the database. Just by seeing this, we already came to the insight which faced some problems to reach a perfect model which would predict the sales perfectly. So the first part of our model building starts with deleting the unpredictive locations. We deleted or discarded all the locations with low explanatory value in 2 different ways. Firstly, we deleted all the locations where there was no significant correlation between yield and bags sold, so all the values above 0.20, p-values above 0.20 were discarded. After that, we also deleted all the varieties where less than 3 varieties were tested on that location. After those 2 steps, only 29 out of the 140 locations which had data for sales remained. Next, we wanted to incorporate in some way the influence of the graduation year, since bag sold values between graduation years are not comparable due to weather conditions, marketing strategies, or the behavior of your competitors. We just decided to make a factor for each year. You can see for year 2012, for example, which was a really good year, received a factor of 0.87 in order to relativize those high numbers. I leave now the word to Robert for the next part of the model building.
Thank you, Charles. I will now go through our model step by step and explain all the predictors we were using. I want to start with yield and RM, since those are the 2 main quantitative variables in the data set. So we really think that yield is the most important predictor since it directly influences the sales volume of the farmers and the profits that the farmers can make. So we gave it a high importance in our work. Secondly, relative maturity. The influence of relative maturity on the sales volume is a bit more complicated than that of yield, since generally it determines the time to harvest. But a problem we've faced is that the RM is actually correlated to yield. So a seed that takes longer time to mature, generally speaking, has also higher yield. And that's not good for our regression, since we desire variables that are not correlated to each other. Thirdly, we also decided to incorporate the variable RM squared, since we realized that the relationship between RM and backsold is actually quadratic. Moving on, we also wanted to somehow incorporate the data we received on check varieties and elite varieties. Check varieties, since they act as a benchmark in the selection process of Syngenta, so future elite seed has to, of course, perform better than the check varieties. Same thing for the previous elite varieties. Of course, future elite varieties also have to perform at least evenly or better than past elite seeds. Another insight we have is that also we think that yield has to be seen more as a relative measure in relation to check and elite yields. This can be illustrated by looking at this table here. In orange, we have two yield values. One is 44 bushels per acre, the other one is 52 on two different locations. So intuitively, you would think that the yield of 52 is more desirable. However, if you compare it to the same, to the yield of the elite seeds on the same locations, you will actually get the insight that the yield of 44 is better than what most elite varieties can do, and the yield of 52 is worse than what most elite varieties can do. So we built those two factors here just by dividing the yield of a variety on a location by the mean yield of the check seeds on a location, divided through the mean yield of the check seeds on that location. Another idea we had is to create location clusters. We think that the different testing locations provided in the dataset correspond to different markets that Syngenta can target with the seeds. And so we wanted to cluster locations with the same characteristics. We did this clustering on yield since we think that locations with the same yield have similar characteristics, for example, geographic location, weather conditions, etc. We know that this is not perfect, but we just didn't receive data on the exact locations geographically, etc. So we did what we could. So our idea is that, of course, a future elite variety has to perform better than the average of the seeds on a location cluster. And here you can see our clustering. We got 4 clusters in the end. We have high yield clusters, low yield clusters, and also the total number of locations per cluster. One last idea we wanted to incorporate into our model is we wanted to let those location clusters interact. The idea behind this is that we think that if a seed performs good, not only on one cluster, but on several clusters, this is actually desirable for the sales volume of a seed. And we think this can be explained by economies of scale. If a seed can be offered on several markets, production volume will increase. The economies of scale will thus reduce the production costs. This advantage can be translated to the customer by reducing seed prices, and therefore the market share of Syngenta will increase, which will result in a higher sales volume. Okay, now that we know all of the predictor variables we used in our model, I will give the word to Henri, who will conclude our presentation and talk about our results.
Well, thank you, Robert, for this marvelous presentation. So once we had our final model, we looked at our adjusted R-square, so which is for 61%. It's actually not in the 90s, which would allow us to really predict significantly or back sold, but 61% is actually really good considering all the data missing that we had in our data set. So once we look at our predictors, we got 18 of them. So how did we get 18? We used the backward stepwise elimination, which allowed us to keep all the predictors whose deletion would have a significant deterioration effect on our model fit. And as you can see, out of those 18 predictors, we have 15 who are actually significant to the 90th percentile with a p-value lower than 10%. So those are the ones we really looked at. Once we used our final model on the test varieties that we received from Syngenta, we went ahead and selected 5. As you can see, we didn't just select the 5 with the highest amount of back sold, because this one and this one, we decided to discard them as they are of the same family as this one, and same family means same relative characteristics. So they would have cannibalized each other on the same markets, and we really wanted Syngenta to be able to spread their wings above all the markets and not just some couple markets. Another thing we would like to point out is that when we went on Syngenta's website, we noticed that only commercialize only a couple of seeds with the same RM, and lucky for us, we got only 2 seeds that have the same RM, and all the other ones are completely different. So now, what are the limitations we actually faced during our work? First off, we had challenges in the data sets. As mentioned before, we had only 2 quantitative variables, which is not really a lot. It was yield and RM, and we noticed there was a collinearity, which gave us a big interval when we did our predictions with our final model. Secondly, out of the sales data, only 33 seeds out of the 15,632 actually had sales data. And out of those 33, only 6 could be considered as elite varieties with more than 1 million bags sold. So it's really not that much. Something else that could have helped us are the strategy of Syngenta, and especially the pricing. Also, the rest of the characteristics, like mentioned by Charles before, of the seeds could have helped us better the fit of our model. The information about the competition of Syngenta would have helped us actually focus on different markets than the competition is actually focusing on. And finally, like mentioned by Robert, the geographical sales and demand, we only had aggregated sales and demand. We would have liked to have more demand and sales per location, and actually also know what the numbers of the location meant geographically wise. So now for a quick conclusion about our work, we started by doing clusters on locations, so we could see what the characteristics of the seed were performing on each locations. By letting those clusters interact, we actually had a business sense of more wanting to create economies of scale for Syngenta, and actually that they could make more money. When we selected our seeds, we went ahead and checked against the previous elite varieties, so actually that their characteristics would make sense towards Syngenta's strategy in the long run. We are, like mentioned before, business students, so we don't have a strong statistical background. So every decision we made, we truly wanted to have a real-world impact and actually have a business sense behind everything, not only numbers. We indeed discarded a lot of locations because they made more noise than anything else towards our model, and I think that's a strong point. Finally, yes, we have a lot of predictors, 18 is a lot, but 15 of them are significant to the 19th percentile, and our R-square is 61%. That's it for us. If you have any questions, please feel free to ask.